Welcome everyone. The session today is about building an API using DAB, API Management, and Azure Container Apps. Let me start from the story of DataSprint. DataSprint is they have a very classic need. They need to exchange some data with their business-to-business partner, and but today they are using an old way to integrate with their partners. So they use you can imagine the classic flat file system. This means that every time they have a new partner, it's a time-consuming task. They need to integrate with the partner, for example, because they have someone that needs this file via SFTP, the one with FTPS, etc., etc. So not only for new partners, but it's also time-consuming every time that they need to expose a specific set of data, so a new view. So they want to invest this time not in integration, but they want to focus on new feature, on new way to exchange in a way modern way. Okay, so that brings me to the goal of DataSprint. So they want to surface these data sets in a secure way, in a performant way, and in a scalable way for their customers. On the right, we do have their starting point and some requirements. So those data they want to surface are already available in terms of SQL views. They are ready to be consumed. So the way to interact with this data is read-only. So no needs to create data to perform changes on these data sets. They are looking for an interoperable format, so a format with a large ecosystem. You can imagine REST APIs. It fits good for their use case. It's mandatory, extremely important that data is secured, so secure access, for example, going via Entra ID. They do want to avoid for every new views or every new partner development cost. And for their developers, they do not want to have a steep learning curve, so no needs to use Kubernetes and that kind of complexity. They want something very simple. That brings me to the approach for this use case. So we decided to approach it with the PaaS first. Why PaaS? Because we can do more with less. And we will look at this problem from three dimensions. The dimension of fast innovation. So to make sure that we can leverage the Azure power, those pre-built services that Azure has, to make sure we can go fast. We want to optimize the cost. So we want to configure efficiently our APIs, our endpoint to not spend more than needed. And then we want to operate with confidence, meaning to empower developers to use the right tool for better security, resiliency, performances, and so on. So with this in mind, this three steps approach, let's start with the first one, so with innovate faster. Here we just look at Data API Builder. So Data API Builder known as DAB. It's something that has been open source in 2023. It's an open source tool launched by Microsoft that allows you to turn very quickly a view, a table, a store procedure, or a collection from Cosmos DB very quickly into a REST or a GraphQL endpoint. It supports full pagination, sorting, filtering, and so on. So you don't have to build from scratch all of these utilities that helps you to interact with data. It works today with 4 types of repositories. So with SQL, Azure SQL, or also Azure, SQL on premises, if you want, Postgre, MySQL, and Cosmos. It is built with security in mind. What does it mean? That even if it allows you to expose a database, it's not going to expose the full database, but just only what you need. And you can integrate with Azure Active Directory and OAuth 2. And you can also leverage some authorization via DAB policies, which extract a claim, for example, from your JOT token and filter your SQL data by using the JOT token. It also allows an easy deployment modus because it's distributed as NuGet package and is also there as containerized image. How does it work? DAB, it can start with 2 things, just a configuration file and a connection string to your database in the case of REST. And for GraphQL, you need still the configuration file and the schema that describe your objects that you're going to expose. Then there will be an in-memory abstraction, and then of the schema of this configuration file, and then it will be translated into a REST endpoint. So you can, from your consumer point of view, you can just go and fetch the data via this REST endpoint. So that's how it works in a nutshell. How to use this tool? You can just use the .NET tool installer with Microsoft Data API Builder. Then you need a connection string, and you can use the DAB CLI to initialize the configuration file where you can define which entities to expose. That's the next step. In this case, DAB add special deals. That's a view that we want to expose from our SQL database in this case. And once you add only that entity, or with multiple DAB add additional entity to your configuration file, then by using DAB start, you can just access via a REST endpoint in this case to your database. So one of the things here, when you expose your database, so make sure that you don't directly expose your model to the outside world. That is clearly an anti-pattern for multiple reasons. Some of those reasons are here in this list. But this is in general for every technology. Take the time to understand how to use it and how to avoid the misuse of the technology. In our case, everything, our views are already ready to be used to the outside world. We selected the field that we want. We are sure that the data types are the one that we want. So everything is ready to be consumed externally. So no worries for this very well-known anti-pattern. Okay, let's just quickly check a demo of DAB. So I'm starting here with to expose a table in this case. I just use a little configuration file. Then I need to install the DAB tool. In this case, I update it because I already installed my machine. Let's see this running. Voila, we are running the version 0.10.21. Then I do create with this command DAB init an empty configuration file that use my connection string. The file is added here. There is nothing special except the connection string to my SQL environment, and everything is empty. I'm saying here that I want to use the development mode. We will see in a while why this. And then I go back to my table and I want to add one view. And I say that I allow, for this example, the anonymous access. So this special deals has been added to the configuration file. Here we are, what I want to show. To add, and then as a final step, I can run my DAB start, and DAB will take care of, let's say, create this public endpoint. You can see that is starting up. Now my DAB is running at localhost 5000, so I can then go and, in this case, just get all the special deals. You can see here it's coming back everything from my database. I can check here on the logs because I'm in development mode. Which kind of query has been executed. I can get a specific deal with this notation, the number one. I can go and filter. In this case, we're using discount percentage. I can select some fields, only the one that I'm interested in, and so on. This is what very quickly the DAB allows me to do. Now, let me go back to the slides. Okay. And let's move to the other part, what about optimized cost. So now I have this API, or this data API on premises, and I need to make it available to my customers. So I said that I can use, we can use DAB as a container. So we can, the easiest way to host a container in Azure is using Azure Container Apps. it's an offering that abstract all the complexity of Kubernetes, and it's really extremely simple to run. So what do I need to run a DAB? In this case, I need to have an Azure Container Apps environment here at point 1. Then I need to, because DAB is working on based on the DAB configuration file, I need to add this configuration file to the storage account and link the storage account to the ACA environment. So my Azure Container Apps application can fetch and mount this file and use this file. So why, again, Azure Container Apps, I can focus on my application, and the infrastructure is extremely simple. And then because Azure Container Apps leverage KIDA, I can scale to 0, so pay nothing if I don't, or really a small amount of money if I'm not using that view in this case, or that endpoint. So in this case here on the left, I set up the infrastructure, I set up the environment, I create the application, and then using a specific convention in my script, I can host 0 or 1 customer. So, but then we said that we have our use case, our rapid data company. They do have multiple customers. They want to expose the same things in a different way, and we want to keep the cost under control. We can leverage, we can create 1 endpoint per suppose customer or per view. In this way, we can scale dynamically based on event. So if the customer endpoint is used more, I can monitor the requests that are hitting that endpoint and scale up, for example, up to 3 if I have more than X HTTP request, concurrent request. And then I can decide that, for example, special deals are not used so much, so I can scale to 0. In this way, I can control the cost not only per view, but also per customer that uses a specific view. This is very simple because I'm using the same convention as before and just use a few parameters to decide how many endpoints I do have. And then the next step is like, okay, there is something wrong at a certain point of time because we are having too many endpoints. So this means a bigger attack surface is complex to consume, and it's also complex to maintain. You can see here at the bottom, if with this approach and container apps, I will have a very complex URL to be given to my consumer. With this in mind, what can be the next step to simplify and making this setup more secure is just to see which kind of tool we can give to our developers to have a better secure and less complex setup. So in order to do this, what we can do to achieve, to make it more secure and more manageable, we can turn our Azure Container Apps from public to internal, so will not be anymore accessible from the internet, and we can put something on top of our, in front of our Container Apps, in this case, Azure API Management. For this little example, I also host Azure API Management in Azure Container App, so I'm leveraging the self-hosted gateway of API Management. And then I can also, by introducing this design, I can decouple the public version that is controlled via Azure API Management with the internal version that is controlled, that has a different life cycle. With this setup, it's really, voila, I just give a single endpoint to the consumer that is called, in this case, ingress, and then I can, with this facade, maintain the 2 different life cycles. So I can also expose which operation, decide which operation to expose and which one not. I can also implement throttling. I can implement throttling at API management in this example. I always advise my customer to implement throttling in a different way. So throttling some configuration in case of successful request, but even throttling harder in case of error. I can implement resiliency at 2 sides, one on API management backend or on Azure Container Apps, leveraging the resiliency policies that has been announced a couple of months ago. And then I can implement also using API management policies. I can implement policies that mask internal details, so we are sure that what's happening downstream are not surfaced back to our consumers. So what happened then? We end up, so we move from a situation where we have multiple HTTP methods, multiple endpoints exposed, with a solution more easy to maintain, also easy to consume, and also more secure that we have on the right. So we expose only the view that we want, the method that we want. We give the flexibility to our customer to fetch the data in a secure way as our customer is requiring. So that brings me to the takeaways of this session. So we were able to quickly expose a data API using DAB. We turn a SQL database very quickly and fast in a REST endpoint. We were able to keep the cost under control to have a multiple configuration per customer and per view. We can scale to 0 if needed. And then we secure our endpoint using the power of API management and the power of resiliency policies introduced by API management or Azure Container Apps. That's everything for today. Thank you for attending this session.